Okay, once it is ready, I will share the recording with you guys. All right, let's start our. So the question is the ratio of the restitution impulse to the defamation impulse. This is known as the coefficient of restitution, and you can also calculate it. You can also calculate it using the relative velocity formula. Let me show you this formula. E So I think I can move it away. Yes, it's good. So look over here, relative velocities. I would say final, which is after the impact, divided by initial relative velocities. REL, just the abbreviation. So over here, and it is always along the line of impact. Okay, I will explain this again, but just a brief heads up that where are we heading to, that what, and this is a very useful formula. It gives us one more equation, because if we have more equations, we are better off to find out more unknowns. So I'll teach you one problem, you will be happy to see that what is the benefit of using this formula. So let me show you, like we x, I'm writing x because I'll show you a final. So let me show you. If I write down, excuse me, can you write down like this? Final V body A final, V body B final, V body A initial, V body B initial. So I'll teach you why did I write down x component in a bit. When there is an oblique impact, you will always find out that velocity component which is along the line of impact. Line of impact is a line where both centers they are joined by that line. For example, if I say this is one particle, this is another particle, okay, and the line of impact is the line joining their centers, mass centers, okay. So this is the line of impact joining their uh, mass centers, okay. So if this particle is at an angle, if this particle is coming at an angle to the line of impact, then this is an oblique impact, and in that case uh, you will use the coefficient of restitution for the horizontal component, or the component which is along the line of impact. That's very important, because you see, I'll tell you. So this is my, if I, this is my y direction, suppose this is my y axis, this is my x axis. So this component, you have to resolve this, and this component is vx, this component is vy. So I'll teach you in a bit, but this is the main takeaway from this discussion is that the coefficient of restitution will always consider those velocities which are aligned with the line of impact. That's the main takeaway. But you will also see some more formula which I'm going to show you in a bit. So let's see. So let's see the next slide. I was thinking I was teaching this slide here. By the way, I have already assigned you some problems for the quiz which is coming next Thursday from this chapter. If I'm able to finish this chapter today, it's good. If not, I still have Tuesday. I might be left with just two or a few more slides, which I will be covering on Tuesday. So the quiz will be given from the whole chapter. I sent you an email. Which problem do you should review? I'll give you the questions from those problems. Let's practice this. Today's lecture is kind of practice of that quiz. Okay, previous lecture. So whatever we're learning. So you see this. This is an example where the ball is a rebound. It's rebound from the ground, and it does not go to the same height because some of the energy is lost to sound or heat. But the coefficient of restitution will determine what is the loss of energy. So I'm going to show you coefficient of restitution, which is suppose if it is 0.8. This has 0.8 means 80% energy is restored after the collision. Restored after. That's what it means. You see my point. If it is 0.8, it's 80%. So if it is 1, it means 100% of energy is restored, and that is the special case. So E, if it is 1, I would say elastic collision, pure elastic collision. Have you studied strength of material, elastic strain, like stress and strain in the elastic limit? Have you studied that one? So unless the material starts deforming plastically, it is still in the under the Hooke's law region. So this is a similar concept. The energy, it is restored. It is after the collision. It is purely elastic collision. But if E is 0, which is the extreme other side where the energy is completely plastic. Now, no more elastic. The plastic deformation, we call it a plastic collision. And what it means there, no separation after collision. No separation after collision. Inelastic or pure plastic. Okay, so we will study this in examples. I'll teach you. So, but in real life, now it is true. Like I can show you one example where the bullet was fired into the block and it was embedded. The bullet, it was fired and it got embedded inside the block. So they did not move apart after the collision. They become one part. And we saw such problems in the previous example. Then the both bodies, they're coupled together and the springs deflect. We will study more about it. So let's go. Have you understood the concept of E? It's important. This gives you another equation, and we are happy. And I'll teach you some more some more equations in a bit. So equations are important for solving the problems. So in this case, this slide is telling us, is this an oblique impact or a central impact? Can you tell me what type of impact is it? Oblique. The reason is the line of impact, the velocity of that ball is at an angle, which is initial speed is at an angle. So that's why it is an oblique impact. How can we determine the magnitude? We can find it out in a bit using the 2 or 3 equations. So I will show you those equations in a moment. Yeah, these are the equations. Please start writing down. Okay, this is still not equation, but this is the definition of central impact and oblique impact. As you can see, central is that impact where the particles collide in such a way they are moving along the line of impact. Like 2 trains, rail cars, they are colliding and then they go away from each other. You see my point? And if the 2 billiard balls, they are colliding at an angle, this is an oblique impact. Have you understood the definition of central impact? And coefficient of restitution will always be considering the velocities along the line of impact. We will resolve it. Whenever you see oblique impact, you have two components of velocities. One is along the x direction, which is we can say this may be x direction, this is y direction. So in this case, this is x is the line of impact, y is perpendicular to the line of impact. So momentum is conserved. Momentum is conserved before and after the impact. So let me show you over here the next equation. It's not the equation, but the concept. We are still understanding the concept. So the two particles, they are moving along the line of impact. When they hit each other, look, this particle, it is moving along this direction. Therefore, the force coming for this particle A, the force is to the left. When the other particle collides this particle A, the force direction is towards the particle A. You see my point? And this, since this is moving to the right direction, the force is, which is P, the impulsive force. This force is negative P dt. You see my point? Do you know the formula for linear impulse and momentum equation? So if you remember that initial momentum and integral of dt equals to m final momentum. But here in this case the force is to the left, so I'm going to change this sign to, or you can say plus negative p. You see my point? Because the force on particle A is on the left side. The velocity of particle A is to the right. The force exerting on the particle A is to the left. And from here you can, if I ask you, can you find out force P? If I tell you final velocity and initial velocity, you will use this equation. There is another equation, if you remember, conservation of momentum principle, ma va1 plus mb vb1 equals to ma va2 plus mb vb2 for two particles. All the initial momentum is defined as the product of mass and velocity. All the initial, before the impact, the velocities and the product of mass and velocity is the momentum for all the particles. Here there are two particles, for example, they are equal to the, after the collision the momentum is conserved. And this is applicable only for the line of impact. The velocities are for the line of impact. In this case, it is x, or I can write down line of impact. You will consider the velocities along the line of impact. But there is another formula, momentum conservation. So if the particle, look, if the particle here, so if I show you the particle here, is an oblique impact. So look at here, I'm just considering the left hand side. Look at the left hand side where the particle A, and after the collision, this direction has two velocity components, and this direction has two velocity components. Agreed? So you have to resolve each velocity vector along the line of impact and perpendicular to the line of impact. And I already mentioned that this is the line of you for the momentum conservation. How about the momentum conservation principle along the y direction? Because this is also true that there is a y component of velocity. So let me show you for y direction. You will do for both body A and body B. MA VA y1 equals to MA VA y2. MB for body B in the y direction, MB VB y2. So you get two extra equations. Along the y direction, you will consider the momentum for individual particles separately. That's important. This is only true for oblique impact. For central impact, you are using this equation, this for center. And there is another equation for the one which I showed you for E. So for E, I'm going to show you for E. Look over here, E equals to relative velocity, final relative velocities. Okay. If you take a look here, VB2, this is the final velocity of body B. So I can write down VBX2 minus VAX2. You see my point? In the numerator, you will only use the final velocity differences. And in the denominator, you will use the initial velocity differences along the line of impact. Don't worry about the perpendicular to the line. That's how you will consider VB x1 minus VB VA x1. Sorry about this. This is VA. This is VA x1. Now here students can ask professor, can we swap their directions? You can swap. It's not a hard and fast. You can swap only in that case when you see a negative sign. If the velocities, the difference is negative, you swap their positions. You should not have a negative sign either in the numerator or the denominator. You should, because E goes, look, I told you that E is like 0.8. So the minimum E is 0, maximum E is 1. There is no negative E. Or you can take absolute value. So if you are getting negative answer, don't worry, you can just take the magnitude of that value. You see my point? So I have explained almost every theory to be to get prepared for our question. So let me show you one more slide here. So I think I was here. You see, we have done this equation. This equation is conservation of linear momentum principle. We already have written down the same equation. We already written down. So let's go to the next slide. You see my point? This is the formula. Relative velocities after the impact divided by the relative velocities before the impact. In this case, the collision is central impact. If you look at the heading of this slide, central impact. Therefore, we did not consider X or Y. Y can never be like perpendicular to the line of impact. You will not find the coefficient of restitution. You see my point? So here, this is a special case. Okay, when energy is completely restored, it is 1. When energy is completely destroyed, no separation after the collision, which like bullet embedded into the block. This is the case of plastic collision. Yeah, you can see a 0.95 glass when it is hit by on glass. You may see some glass particles, small balls. I have seen some small jumping balls, so you can hit them and Yes.
Since glass is so close, so how fast does it have
It's a material property that
more
more of a material property. It suddenly breaks, but it
I know it breaks
very quick. The brittleness,
ever see
like smoothness. If it is more smooth, then it is more elasticity inside this. Okay, the glass, if you microscopically, which is not our field for dynamics, we consider the microscopic glass is very smooth as compared to wood. Therefore, we lose a lot of energy. Okay, guys. Now this is another formula here. The kinetic energy difference equals the work done. So plastic collision, energy lost is maximum, although energy of the combined masses does not necessarily go to zero. We can still apply, even after the bullet, when it is fired to the block still moves to the right. So final velocity conservation of principle of the velocity. We might have done that problem before, that the block was lifted upward and what is the velocity. So energy conservation principle will be still be applied here. So look at here, there are four equations. They are very important equations. They should go into your formula sheet. Number one, equation number 1 and 2, they are perfectly valid for both kind of impacts, central and oblique. Equation number 3, for individual particle along the y direction. You see my point? Equation number 3 and 4 are for individual particles. This is, I would say, equation number 1, 2, 3, and 4. Okay, so when you are considering oblique impact, you have extra two more extra equations. That's a that's a beauty. Like we have more equations is good for us. More equations, and you can find more unknowns. You see my point? So in the coming question, this is the whole, you will solve all the problems using these equations, or maybe a few some more like energy conservation and the conservation principles. So what is that principle I'm going to teach you? I already taught you the energy conservation. If you remember, all the particles kinetic energies before the impact equals to all the particle kinetic energies and potential energies after the impact. So this is the energy conservation principle. So it's we already studied in chapter 14. You remember that? So we might need this one as well, but at least we should know how to solve the problem using the momentum. So this is a logical steps. So if you see a problem, the logical steps are that you can use these equations. Again, I'm emphasizing here. First, you define the x-axis. Typically, x-axis is defined along the line of impact. Y-axis is along the line of perpendicular to the line of impact. And then you will use the momentum conservation principle, coefficient of restitution equation. And for oblique impact, you will have two extra equations along the y direction for individual particle. Let's do this problem now. Please draw this diagram. Here, the ball is striking a smooth wall with a velocity VB1. Let me ask you, is it an oblique impact or a central impact? Good. This is an oblique impact, so we will have four equations. Okay? So I'm going to show you each equation one by one. We have to find out the velocity of the ball just after the impact. The initial velocity is given. I would first of all resolve this into x and y component. So what is VB x1? that is equal to VB1 cosine 30. Can you help your open your calculators and tell me the answer? 17. Can you tell me what is VBY1? I think it is 10 because I know sine 30 is 0.5. Agreed? Now, in order to find VB2, what do we need? At an angle like right angle triangle. You remember the rule of a right angle triangle, the magnitude formula? Do you remember that? VB Pythagoras theorem. VBx2. You need the x component, VBx2 whole square, and VBy2 whole square. This is what you need. And and we know one more thing here, that the in the y direction for each particle. So for y direction, this particle, if you take a closer look, or I can redo the picture here for your comprehension. So let me show you here. I want to show you the y direction. The momentum is conserved in the y direction. This is for oblique impact. Okay, y direction, and we know that y direction m sub b vb y1, m sub b vb y2. You remember I told you the third and fourth equation along the y direction for individual particle. This is the momentum conservation along the y direction for individual particle. You see my point? Wall is not moving at all, so don't worry about wall. Okay, so what is VBY2? MB is cancelled. Okay, what is this? Is VBY1, which is 10. So we are happy that we found VBY2, agreed, which is 10. So now we have to find out VBx2. That's what we need. You see my point? So how would you find it out from the, and you need another equation, and I would use coefficient of restitution, because in the question, look, we have been given that 0.75 is the E. So what is the formula for E? So if I show you the formula, VB x2, you see, minus 0, minus 0, because the wall is not moving. You see my point? So what is VB x2 from here? E times VB x1. VB x1 is 17.32. So can you tell me 0.75 times 17.32? What do you guys get? I get 12.99. Do you agree with me? One student agrees, so it means this is correct. Now we are happy because the magnitude formula, we found both components. VBx2 has been found, which is 12.99, and VBy2 we already found. So what is the answer in the magnitude? If you plug in the magnitude formula, what do you suggest me that, Professor, this is the answer for this magnitude formula? Do you get 16.4 in your calculators? You agree? This block, that block, that block. All right, now we are happy that we have found the magnitude. How can we find in a right angle triangle? If this is right angle, what is the angle? If we know the VBy2 and VBx2, if we know the, can we find the angle? Tangent of opposite or adjacent. So right angle triangle tangent VBY2, which is 10 over VBX2, which is 12.99. And what do you get in degrees? Do you get 37.6 degrees? All right, guys. So with that, we have done this question. And you see, I'm going to revise it for you. The question was asked to find out the final velocity after the impact. So then I gave a thought process. Let's find out the components first, and then I know the magnitude formula, so that I should see where am I heading to. First, I want to see what do we need to find out. So I'm missing VBX2, VBY2, and I know that oblique impact has momentum conservation perpendicular to the central impact. So from there I can find out the y component, and I know that coefficient of restitution gives me another equation which is always along the line of impact, and that gives me another component, and therefore we find the magnitude form. Oblique impact is at an angle to the line or joining their centers. Here the center is this one, and the wall is anywhere you can take the center, and this is the line. This is the line joining their centers, but the ball is at an angle. So, or if it is striking, you can draw a line and where it is coming from. Yes. Just initial is sufficient to define obliquity.
So my question is, it started off at velocity of 20 and got to the final velocity of 16.4, so it lost some velocity.
Yes, it lost some velocities due to some friction inside the wall. Therefore, we rebound the ball and it loses some velocity because of the friction inside. So have you understood this concept? So let's do one more problem. I'm glad that, will you be able to solve such problems in your coming quiz next week? I would, if I were you, I would spend some more time, at least 1 hour more. Or are you busy? Very busy, guys. This is the solution, and moving. Yes. Three. Yeah, we will stick with just two objects. Okay, can you answer the first question? What do you suggest your professor? Can you try again? A. A is correct because it is possible, because we don't know the masses. Only coefficient of restitution is not the defining answer. It will tell that the final velocity of one particle will be greater than. The masses are also playing an important role. So how about the next question? Can you answer the next part? B is the correct answer. Energy lost during the collision is maximum when E equals to 0, means 0% recovery. You see my point? Debt credit, debt recovery. Are you ready for another intimidating question? It looks intimidating, but it's a good problem for us to review our chapter 12 problem. You know projectile motion? You studied the projectile motion already. So I'm glad that now we are getting the similar kind of question. The question is, the tennis ball is served horizontally. This is important. When it is served horizontally, we don't have the vertical component. But in a projectile motion, we do have vertical component. But in this case, it's served horizontally means VAY is 0. Agreed? But VA equals to VAX 0, which is the same horizontally. Okay, now it is 7.5 feet above the ground. It is 7.5 feet above the ground. So this is my ground and this is my datum line. Let me see. Yeah, this is, let me take this one as datum line. Okay. So can you take this one as datum line? Then what it is saying, it strikes at point B. So it strikes at point B with a certain velocity, initial velocity. Okay, guys. So it is asking you, can you find out VB after the impact? After the impact, can you find it out? And VA, can you find it out? Initial velocity. Initial velocity is very easy. Let me show you why is it easy. So remember, x equals to x naught. The distance formula, you remember that? Now here there is a review of chapter 12. Acceleration in the x direction. What do you say me about the projectile motion? 0, because constant velocity horizontal. We have assumed that with neglecting air friction, the projectile fired, it will go like the same velocity throughout. Okay? Horizontal component, constant velocity means acceleration is 0 in the x direction. And this is 0. Agreed? And now x0 is 0 because we are taking this as a datum line. What is x? Can you tell me between A and B? What is the x distance? 20. Good job. So it is 20 here, equals to V naught x times t. But we don't know t. But we have another distance formula, the same formula in the y direction. I'm going to show you how can we find the time of flight. So I can write down y equals to y naught plus v naught y times t plus 1/2 gt square. Now here, y, if you take a look closely, so y is this distance. This is the datum line. And this is this point B is 7.5 feet below the datum line. So I'm assuming my positive is downward. 7.5 feet is the point B. I would say YB so that you should not get confused. YB is the landing point, the distance from the datum line. You agree with your professor? Y0 is 0. Now here comes the question. What is the initial velocity y component? 0. You are right. This is 0. And now plus half g, it is 32.2. You agree with me? Can you, one equation, one unknown. Can you find out t from here? In my notes, it is 0.6825. Can you verify? Any genius? You got it? That's good. All right. One student has confirmed it. Now let's do the next thing. We have to find out. Look, can we plug this in over here and find out the initial speed VA, which is her. So can you find out V0x, which is 20 over 0.6825. This is also equal to VA, initial velocity of the projectile. Do you get 29.3? You see, we are still reviewing the projectile motion, and now the y velocity component. Now I want you to find out I want you to find out VB y component, and so let's do this. Let me show you what is VB0. I would say initial velocity when it lands the ground. What is the initial? So we need to have two components. Look, we have already found the horizontal component because horizontal component remains constant throughout the projectile motion. This is true. And for the vertical component, VBY equals to initial component plus G times T. You remember this formula from your uh, projectile motion? You remember that? Final velocity equals to initial velocity plus GT. So initial velocity is what? 0 in the y direction. What is VBY equals to plus GT? 32.2 times 0.6825. Do you get 21.98? So once it has confirmed 21.98. Okay, look, let me show you what I'm trying to. This is the floor. Okay, this is the floor. The ball, when it hits the floor, it is coming at an angle, and when it leaves the floor, it goes at an angle. So this is, we have already found VBY. I would say VBY, and so this one is VBY2. Let's assume this is VBY2 and VBX2. This is VBX. Now this is the direction. This is my X direction, Y direction. Now guys, I'm asking you, because we have done the first part. Velocity we have found. VB final velocity after the collision. How can we find? It's a similar problem like we did over here. The ball hits the wall. Now the ball hits the floor. We have to find a coefficient of restitution. And coefficient of restitution is along the line of impact. Now here's the deal. Look, where is the line of impact? Is X the line of impact or Y the line of impact in this specific case? Y is the line of impact. You understood this one? So E would be found. Look, I'm going to write down the formula for E. E would be found VB Y2 minus 0, VB Y minus 0. Agreed? Y is the line of impact because the center to center, mass center is over here. Look, this is the mass center, this is the center. This is the line of joining their centers, okay? Not along the horizontal axis. You see my point? You will always resolve along the line of impact for E. Have you understood? And this gives me a y component, VBY2. Once we know the y component, x component, we can find the magnitude formula. Okay, so what is VBY2? VBY2 equals to E times VBY. VBY, you already found it. Look, you see that? And E is given. 80% energy has been restored. You see that? So I'm happy that I found the final y component of the velocity. And what's that? If you do the math, you should get about 15.4. Do you get 15.4 feet per second? Hey, there is a problem. The problem in the solution, the 0.8 is not given. It is 0.7. Let me show you the solution. So if you do me a favor, change this to 0.7. Can you redo the math? Because the problem says something different than the solution. So I want to just remove that. If you plug it 0.7 here, and can you change this as 0.7? E equals to 0.7 for this case. Then it will be similar to what we have solution in our slides. All right, guys, now after we found the y component, can we find the x component? Yes, you can. For oblique impact, we have two extra equations for each particle. So which is perpendicular in the y direction or perpendicular to the line of impact. The momentum conservation. Sorry, here this is the ball, so I would write on M sub B, VB, look, this one, VBX equals to M sub B, VBX2. MB is, and this is the same. Look, this is the same horizontal component. You see my point, guys? Which is equal to what? What was the initial X component? 29.3. Look, VBX2 equals to 29.3 feet per second. So we are happy now. We have found both components of the final velocity using the coefficient of restitution as well as momentum conservation in the in the perpendicular line. And now you can find out the magnitude formula. Do you remember that for a right angle triangle, the final velocity equals the magnitude formula VBX2 squared plus VBY2 squared. Do you remember it? What do you guys get for that? Please do me a favor, find this out. And I'm going to show you the final answer, theta, tangent inverse VBY2 or VBX2. What's that? 27.7. Any genius bars sitting in front of me? 33.1 is the final velocity magnitude. Anyone else who confirms the angle of the shooting ball after it lands on the floor? 27.7?
Yes,
He confirms 27. Okay, guys, now we have finished. This was a lengthy question, and it was intimidating as well. It was not an easy question, but I wanted to go slowly. I did not go rush. I want to go slowly such that you should comprehend what we are learning. It is a combination of chapter 12 projectile review equations plus the new equations, coefficient of restitution, momentum conservation principle. It's a very good problem for you to practice. Will you practice at home again, or are you busy? You have a Thanksgiving holiday coming to spend with your family. Family is important. At least we can, if the families are far away, we can talk to our parents, siblings, say hi. All right, let's go to this is the solution. The magnitude has not been given. Look, over here, the final velocity is in the form of a vector. This is also acceptable. In the form of a vector, I component, y component. Okay, guys? So let's do the last slide. Are you ready for the last slide? And the last slide is, this is the, you have to do it at home. This is the answer for that one. And here I would say this B is the answer, but in our slides solution says C, but I will say it's B. You have to check it. I'm trying to save time because this is similar problem what we already did here. Now here the question by this gentleman, you asked me if the blocks separate. This is the same question. When the blocks, they do not embed, they separate after the collision. So you can practice. It's not a big deal. MAVA1, MBVB1 equals to MB, MAVB2 equals to MB, MAVA2. All right, so now let's go to the next section, which is final sections. Before I go to final section, I want to take the attendance. And I want to stop the video recording. Do you want me to share with you